So while we go around the Navagraha Gudi in temples, the Navagrahas themselves are going around us all the time up there in the sky. I am Kishore Kumar. I welcome you to today's talk on the astronomical basis of the Hindu Panchanga. So in the talk today, there are two major parts to it. One is astronomy, of course, and the other is the Hindu Panchanga, and I will tell you soon that it is actually the Hindu calendar. So let's look at the calendar part first, get it out of the way. Then I will get into the astronomy part of things. So if I talk about calendars, you may think, what the big deal? When everybody knows there is January, February, March calendar. But let me set some context. That's all I want to do today. And to set the context, I want all of you to imagine that you have been invited for Kaun Banega Karodpati. You are in the hot seat. And I am Amitabh Bachchan. And the next question, agla sawal, 10,000 के लिए, which calendar did Krishna Deva Raya use? A, January, February, March. B, Muharram, Safar, Rabi al-Awwal. C, Chaitra, Vaishakha, Jyeshtha. Or D, I mean, you have to wait for the D, none of the above. C, are you sure? Lock kiya jaye? You can't change afterwards. Of course, the answer is C. Chaitra, Vaishakha, Jyeshtha. It cannot be any of the others. But the point I'm trying to make is that a calendar such as January, February, March, if you think about it, Vasco da Gama landed in India about 11 years before Krishna Deva Raya became the king. So it was a very new calendar. It was a newcomer in those days. So obviously, Vijayanagar Empire wouldn't have picked that up. The other two calendars were indeed existent in India. Right here in our country, there were two calendars which were broadly used 500 years back. This was used north of the Krishna River and this was used south of the Krishna River. But both those calendars were used, where today there is a universal calendar all over the world, but 500 years back in India, definitely there were these two major calendars and probably more. And these were not used at that time just for religious purposes. These were used for civil purposes also. So if there was a trade fair in Vijayanagar Empire, how would they publish the date of the trade fair? They have to use this calendar and maybe translate it into that. And they managed with multiple calendars in those days, which we have completely forgotten. We believe there is only one calendar, all over the world is universal. But there were two. And I am a Hindu and my interest is obviously in that calendar, and I started investigating the basis of this calendar. The astronomical basis which I found was quite profound and mind-bending actually in some ways. So this calendar exists today in the form of Panchanga. This is familiar to all of us, but we think this is a religious artifact. You know, it's got Bhagavan Sri Krishna's picture, there is a Vigneshwara picture, it's always in local languages, this one is in Kannada. It's published by Udupi Pejavara Matha. And there are many, many religious institutions which publish this, and some non-religious institutions also. But this calendar, if you open it up and look inside, you will find something like this. A lot of text in there. So how is this a calendar? I will draw your attention to these two parts, where here you see there is a Gregorian date sitting inside the Hindu Panchanga, 28th February 2025. And this whole thing down here, that column, is nothing but February 13th to February 28th, and the 28th being the same one, which is coming right here at the bottom. So this has clearly something to do with dates and calendars, and then a lot of things are written on each line. What are those things? Those are all calendaric elements, and it really hit me that this is a calendar. This format is not intuitive, but when I looked at this format, which I came across about 10 years back, then it came to life, because we all know this. You know, we like our calendars to have boxes like this, a box for each date. And this is nothing but the Gregorian calendar, this is February, but inside those boxes there are a lot of things written there. What are those things? That is the subject of today's talk. At least some portion of that I will explain to you as we move forward. And what I found was that this calendar of ours is completely based on astronomy. Even the modern calendar is based on astronomy. It's based on the fact that the Earth's orbital period is 365 days. That's 1 year. And that pretty much is all the astronomy in the modern calendar. The second astronomy there is sunrise, sunset is a day. But the Hindu calendar, there is lots more astronomy, which I am going to try and uncover in the next 60 to 70 minutes. So the astronomical basis of the Hindu calendar I'm going to talk about, I'm going to take you from that view and that perspective to something like this. So what you see on this side is the astronomical Panchanga, and this has got some of the things which are there in the real Panchanga with some timestamps marked here. And when you see this picture again a second time, it means we are coming to the end of the talk. Good. Now, one of the basic things about the Hindu astronomy on which this Hindu calendar is based is that it is geocentric in nature. So what does geocentric mean? Geocentric is actually saying the Earth is at the center of the universe. So problem ho gaya na? Sun, moon and planets orbit the Earth. We know this is not true, this is not right, so why are we still looking at this? How does it matter? But let me ask you, every day morning I see the sun rises in the east, goes overhead, sets in the west, so sun is going around us, no? It happens every day and night, and still we say sun doesn't go around us. So we need to know the reason for that is that the Earth is rotating. So the sun really does not rise and set. जो दिखता है वो होता नहीं है. On the other hand, Earth is spinning. That means every one of you is right now spinning, and I am also spinning. I can't see it. You're all looking like you're all standing very still, sitting very still in your chairs. जो होता है वो दिखता नहीं है, जो दिखता है वो होता नहीं है. सब माया है. And we are living with this Maya day in and day out, and this Maya is what our ancient astronomers lived with. Whether you take the Hindu astronomers, Greek astronomers, Islamic astronomers, Babylonian astronomers, they all lived within this Maya only. And they did all their work, all their astronomy, all the science based on exactly what they observed with their eyes. So let me drive that home a little bit more. Solar system, everybody knows. Can anybody tell me, can you and me ever see this view in real life? And why not? Can somebody... Scale is too large, you are getting there. These lines, of course, will not be visible because they are all conceptual lines. Really, those lines are not there. But really, you and me cannot see this ever because, look, Earth is there. And we are there on top of that Earth. So it's never going to be possible to see this view. This is an outer space view. You'll have to go to Elon Musk, ask him to put you on a rocket, send you far out, look back, oh, there is the solar system. Then you can see this view. But we are standing on the surface of the Earth, so how can we see this? We can't see this. This is not possible. What we really see is this. Every night when you go out, this is what you see. Half of that solar system will be hidden by the ground on which we are standing, because it's all below our feet. Whatever is above, we can see it, but those distances, that moon is close to us, Saturn is far away from us, we can't make out. Because first of all, human eye cannot distinguish beyond 20 feet, 30 feet, but 1 light year, 100 light years, we can't make out with these very weak and powerless eyes of ours. is beyond our capability. So everything will look like, oh, there is Shukra, oh, there is Chandra, there is Guru. And that's what the ancient astronomers worked with. They stood there, there could be Aryabhatta, for all you know. So he stood there and he observed the skies and he looked at the angles and he worked with them. So the point is that this is the reality, this is what we observe. Very different from reality. And it's a matter of perspective. It depends on where you stand and from where you are looking. In life, this makes a big difference. It's all about perspective, right? So reality in this picture is quite complex, but what this giraffe observes is extremely simple. Okay. But in astronomy, it is the exact opposite. Reality is actually simpler. Sun is at the center, everything is going around the sun in one direction only, slightly elliptical orbit, not circular. But reality, since we are sitting on the surface of the earth and looking up, we see some planets are moving in one direction, suddenly they go backwards. Then they move, then they go backwards. It's known as retrograde movement or vakragati. That's happening because everything is whizzing around us. We also are moving around, so the relative motions become complex. And those complexities were handled by the Hindu astronomers in their mathematics. They actually worked with the complex observed model, the geocentric model. But out of all the movements of Mercury, Venus, Jupiter, everything, we are really interested in the movement of two things, sun and moon. Moon, though we all know it goes around us, it is our satellite, there's no problem there. But does the sun move? Sun moves apparently. There is an apparent movement of the sun, which I will illustrate to you. There are two apparent movements, one I already said. Sun rises in the east, sets in the west, every day it's going around the earth. East to west, that's that part. But there is a second movement which most of us find hard to observe. It's not easy. Astronomers observed, and they observed long back, thousands of years, millennia back they observed. There is a second movement from west to east. The sun appears to go around us. And that second movement is what gives rise to calendars. This daily movement, though, it's clock, hours, minutes, seconds, sunrise, sunset. But months, fortnights, weeks, etc., not weeks, months, fortnights, years are based on this second opposite side movement, which goes from west to east. So let me give you an animation to illustrate this concept, because it's important to get this geocentric model correctly. So this is the solar system. We all know there is the sun, there is the earth. And I'm also showing you a bunch of stars, Nakshatra mandala. I'm showing you some bright stars like Revati, Kritika, Rohini, Ardra, Aditi, Magha, etc., Magha. Now I will try to show you. So if I am standing on the surface of the earth and I look at the sun, my line of sight is that red line which you are seeing there. This is what I am seeing the sun. If you directly see the sun, your eyes will get hurt. Don't do that. Conceptually, the sun is aligned with Revati Nakshatra at the starting point. Now the earth is moving, but see what's happening now. Now the sun appears to be aligned with Kritika Nakshatra, no longer with Revati. So the sun appeared to move from Revati to Kritika. That is the apparent movement I'm talking about. Not easy to observe in real life. You have to wake up before dawn, go and look at the sky, eastern horizon, see what stars are there, because that's where the sun is going to come up. So it appears as if the sun is moving across the Nakshatra Mandala. And the days are ticking here, 67 days, it's moving from Ardra to Aditi. So this is the apparent movement of the sun. I will not use the word apparent any longer. I will keep saying sun is moving, sun is moving, sun is moving, but this is what ancient astronomers worked with. So now we are halfway through. It's the earth which is really rotating, but for an observer on the earth, It appears like the sun has moved now to Chitra Nakshatra, traversing. Now the sun has come to Jyeshta Nakshatra. So this simulation I did using a software called GeoGebra. This is the only one I have done. It's a geometrical simulation. Beyond this, I will go to astronomical simulation. So Shravana Nakshatra, 280 days. And when it comes to 365 days, sun will be back at Revati Nakshatra, and that is a solar year. All of you know that. $350, $360, $365. Sun is back to where it started. In reality, the earth is back to where it started. But it is this apparent movement which the ancient astronomers worked with. This is the geocentric model of the solar system. This is what is observed by somebody standing on the surface of the earth looking at the sun. And this was known to the ancient Indian astronomers. Now, the similar model I am going to now simulate in an astronomy software called Stellarium. This is a modern day astronomy software. They call it a planetarium software. It's open source. Anybody can download it, put it on your laptop, and play with it. It's particularly useful for young people to learn astronomy. If you go out and observe, you need dark skies, you need good clear days, clear nights rather. Stellarium desktop astronomy, it will work anytime. So in this Ahargana model, this is the model that I created, you will get your first look at Stellarium software. So this is the starting point. So Stellarium has simulated this. This is a screenshot from Stellarium. The whole video is recorded on Stellarium. And I have configured Stellarium that I am in Bangalore, and I am facing north. There is an N at the center. And it's 12th April 2021, 7 a.m. in the morning. I recorded it 4 years back. And there's a date window and time window up here. This is the date, this is the time, 7 o'clock in the morning. Some unspecified beautiful meadow in Bangalore, they don't exist any longer, they're gone. Now, I'm going to step by step build myself to an astronomical model. The first step, what I'm going to do is zoom out. So I zoomed out so much that not only north, you're able to see east and west on the screen. So imagine if you are standing facing north, east will be there, and west will be here. I have to completely swing my head to view. But here, I zoomed out so much that east, west, north, everything came right in front of your eyes. Very, very, very convenient to watch. This is already like magic. I zoomed out so much that this is actually, you'll see a little bit later, this is an outer space view again. Now, the next step of my magic. In software, we can do all kinds of magic. I'm going to accelerate time. So you see this window up here, you will see the time will start ticking and running faster. And as time starts changing, clearly Earth is going to rotate. And the sun is rising. What was it? The horizon has now come right above your head. It's 12 o'clock in the afternoon and the sun has come overhead. Did the sun really move? No, it didn't. It's the horizon which moved. Sun also moves very little. So now I adjusted my camera view a little bit because the next step of the magic I want to show you what I already showed you right at the beginning. I'm going to show you the Navagraha. Not Navagraha, but the Saptagraha. 7 of the 9. In broad daylight, because it's only 12 o'clock, but in Stellarium I enlarged all the individual planets, so you are now able to see here is Saturn, here is Jupiter, and there is Mars. The black disk is the moon, bright is the sun, and there is Mercury, and Venus is somewhere hidden there in the cluster, Shukra. You already saw them in the Navagraha Stuti. They make their appearance back here. Two more Rahu Ketu I cannot show because there is nothing there. They are 2 points in space on the moon's orbit. So Saptagraha, and you know that these 7 give the names to the days of the week, names of the Varas. Next step. So they are nicely there, all of them, but do you really have to imagine they are actually beautifully arranged in an arc, a semicircle here. And that arc is known as the ecliptic. In Sanskrit, that is Ayanavritta. That is the path the sun takes in 365 days. I already showed you a previous animation. Now I'm actually showing you the arc. That is the apparent orbit of the sun around the earth. And that anchors this Ahargana model. And everything is around that. It's because if you take this is the earth globe, all the planets are orbiting in this plane. Little bit tilted like this. No planet orbits like this. They're all in the same plane. That's how nature has organized everything. And that's why all this look like, okay, so that's why there is this east-west arc. And you will find the planets arranged along that arc. Moving forward, let's continue with the acceleration of time. Now the sun is coming in to set in the west. And that is dusk and night. The stars have come out. So night sky, you can see all the stars. Now I'm going to accelerate time because I don't want to go so slow. The moment I speed up time, everything is ticking very fast here up on the top. You can see a distinct movement of the moon now in the west to east direction. You can also start seeing the movement of the sun and Buddha and Shukra. Everything is moving. But this day and night, black and blue, it drives you crazy, particularly since I even speeded up time some more, super fast. Clear movements of many of the planets are beginning to be visible. And who wants this day any longer? Day is of no use when it comes to astronomy. It's actually a problem. You can't observe anything in the day, so I got rid of day. And finally, I have only our Earth left there, spinning and spinning and spinning, round and round and round. It's like that cursor goes in a computer now and things don't respond. So let me get rid of the Earth itself. I don't want the Earth. Now you can see the entire ecliptic, you can see the complete orbit and everything moving right in front of your eyes. Clearly all the movements are visible, and this is a geocentric model, and I don't even need the stars. At least for today's talk, I don't need the stars. This is the geocentric model, and this is, I call it the Ahargana model, because this is my central tool. I will keep on using this in the rest of the talk to illustrate the various concepts of our Hindu calendar. And everything is moving nicely. In fact, if I run this long enough, you can see backward movement, retrograde movement, forward movement, everything will become visible here. But that's not the focus of today. Today's focus is on the Hindu Panchanga. So let me stop this animation here.
Sir, when you showed the previous thing, you showed the stars, like the sun staring at Revati and all that. But in this Ahargana model, it was the other planets that were there. That was a little confusing.
I just ignored the stars in the Ahargana model. I have other animations which I might use later where stars become important, then I bring them on.
So the Revati, etc., were somewhere far away that
no,
were not seen in this.
they are actually near that ecliptic.
Understood.
But I suppressed them. I didn't show them in Stellarium.
Got it. Thank you.
There is an option to hide them.
Thank you, sir. Just wanted to know if these planets orbit in the anti-clockwise direction or the clockwise direction, because they say that in the Olympics, the reason why the races happen in the anti-clockwise direction is because to align with the planetary motions. Is that right?
That I cannot comment on, but like I said in this model, it is orbits from west to east when we observe them from the surface of the Earth. The sun rises east to west, this moves west to east. I don't even use the term clockwise, anti-clockwise. It depends on where. If you're looking at the north, then this is anti-clockwise. But if I turn and face south, it will appear clockwise. Those clockwise, anti-clockwise are relative terms. So I say west to east. In this model which I use, they'll all be clockwise. In some periods, you will find Shukra and Buddha moving, suddenly changing direction and then coming back straight. But that's a side, not for today's talk.
I think it could be a repetition of what you already said because I have a doubt in that. One is that you were trying to show the planets, all the other planets. Is that sort of a zoomed out version or rather a zoomed in version? Because not all are visible from the Earth POV, as you said, right?
Correct. So when I showed you the planets in this animation, I enlarged them in Stellarium. It's actually a 1000 times enlargement in Stellarium, so they pop up. But in real life, except for sun and the moon, all the others will look like stars. They will be tiny and up there, just like stars. You cannot distinguish. That's why the ancients calls them Tara Graha. They look like Tara, but they are actually Graha.
Is it a different topic to ask about how the measurement happened? Because the point that is being viewed is also moving around.
Yeah, the measurement, how the ancients did it is a complex topic, and really I am not qualified to comment on that.
Sir, thank you so far. One question is probably more on you mentioned about Varas. I'm just trying to understand the significance of Vara is one. Where does that fit in, the week? And also, how is that the Gregorian calendar has Sunday and in Hindu Panchanga we have Adityavara or Bhanuvara or Shanivara and Saturday. So where do they come together or where is that?
So I will not go there at all, but I will make a comment on this a little bit later. Bear with me.
Sir, are these observations specific to the northern hemisphere? Are there any instances of Panchang or calendars from the southern hemisphere part of it?
You are right. I mean, this is specific to northern hemisphere. I did everything as observed from Bangalore city. That's how I configured Stellarium. But according to me, hemisphere should not make a difference. It's the direction in which I am facing. In this model, I am facing north. And hence this model operates in a certain way. Even in the south, if you face southern hemisphere, if you face north, I think this same model should work. So let me continue forward. So the source for all my talk today is Surya Siddhanta. Now Surya Siddhanta is a very old topic, a very old text. In fact, the Surya Siddhanta starts at the beginning of a very long 1500-year tradition of Siddhantic astronomy, Siddhantic Hindu astronomy. And it's placed somewhere around 350 AD. 300 to 400 AD, somewhere in that time it was written. We don't know exactly when it was written or who wrote it. It's anonymous. We don't know who wrote it. About 100 years after that came the most famous Aryabhatta and Aryabhatya. That is fairly very strongly dated. He wrote it in 476 AD because there is an internal reference. He actually specifies when he wrote it. And then starting from there, for 1500 years, you had a series of astronomers who were writing astronomical texts, Siddhantas, most of them in Sanskrit. But as we moved further and further in time, at some point in time, this astronomy knowledge actually moved to Kerala, which is right next to us. And starting with Madhvacharya, who is a fantastic mathematician. Astronomy and mathematics are like end to end. They are like one and the same. You cannot separate them. And he wrote texts like Venvarohash, Sputa Chandrapti, etc. Then Parameshwara Nambudri, Drik Ganita, Siddhanta Deepika, all of these were written by Kerala School of Astronomers. Some of them are probably in Malayalam. Now, I have only read a little bit of that Surya Siddhanta, the calendric portion of it, and then the rest of it is there. That much I am aware. And this fantastic tradition of Hindu astronomy, I am afraid, is rather neglected. I very much doubt if anybody reads them and studies them. Probably some academicians do, but there is a thesis which is now coming around that the foundations of Newtonian calculus is found in these mathematics, which were triggered by astronomy. And the calculus developed specifically by Brahmagupta eventually was picked up by Isaac Newton and became calculus in Principia Mathematica. So that thesis is now being worked upon. Many people are trying to prove that, and I think that makes a lot of sense because there is tremendous amount of mathematics in all of these. And to give you a context, this is where Copernicus fits in. And Copernicus coming so late in the day, after him came Galileo and Newton and everybody followed. He is the one who came up and said, Sab Maya hai. Sun is not moving, Earth is moving around the sun. So again, the thesis is that he had access to some of these works as he started developing his theories. So this gives us a feel for how ancient this astronomy is. And this is what I call Siddhantic period. So you were asking about when did the Panchangas start? Clearly they were already well established by this time. But if you go back to Ramayana and Mahabharata, there are references to the Panchanga, there are references to Masa, Uttarayana, Dakshinayana. We all know Bhishma waited until Uttarayana began to give up his life. So these astronomical concepts, the calendric references, 14 years in exile or 12 years in exile, 13th year Anyatavasa. What year are they talking about? Gregorian year? Not a chance. So there are different years they were talking about. So these concepts were well established in Vedic times itself. But the Siddhantic form started here. These are dedicated to astronomy, these texts. Unlike Mahabharata, which is telling a big story and there are some references to astronomy spread all over it. Now let me come to Surya Siddhanta itself. It's a text with 14 chapters. Madhyamadhikara, Spashtadhikara, Triprashnadhikara, Chandra Grahanadhikara, Surya Grahanadhikara. So all of these are discussed in great detail in Surya Siddhanta. My focus has been on this last one, Manadhyaya, different modes of reckoning, time, calendar. So that's what I am focusing on, and there is a lot of detail about this in these two chapters also. And the Surya Siddhanta has things like this. I mean, these pictures are not there in Surya Siddhanta. It is just full of shlokas written in Sanskrit. But this is coming from a commentary in English written by Reverend Ebenezer Burgess in the 1860s. And he has written elaborate commentary explaining with these diagrams the astronomy and the mathematics in the Surya Siddhanta. And honestly, I haven't really studied and understood all of these. I have a long way to go. I'm hoping that there are generations of youngsters who will get interested in this topic and start digging into these. This mathematics was driven by predicting where a certain planet will be at a given point in time as observed from a given point on the surface of the Earth. That's what drove this entire mathematics and prediction of solar eclipses, Chandra Grahanadhikara, Surya Grahanadhikara. My focus is Manadhyaya, different modes of reckoning time. These are Hindu measures of time. Mana means a measure of time, like a Masa is a Mana, a Varsha is a Mana, Tithi is a Mana, year, month, fortnight. These are all called Mana. Plural is also the same. You take a collection of them, that's also a Mana. And Surya Siddhanta lists 9 different Manas. So the shloka in Surya Siddhanta, in the Manadhyaya first shloka, is Brahmam Divyam Tata Pitrayam Prajapatyam. I'm going in that sequence. Guros Tata Saurascha Savanam Chandrama Nakshatram Manani Vai Nava. 9 manas. But if and I put that picture there because this Sauramana is pertaining to the sun, solar. Chandramana pertaining to the moon. And this is a sculpture from Badami, circa 600 AD. There is the moon, and that is the sun. Sun and moon are deeply embedded in Hindu culture. Not just in these pictures. It's, if you come back to recent times, you have songs which say Chanda hai tu, mera suraj hai tu. Tujhe suraj kahu ya chanda. So it's very much the sun and moon are integral part of Hindu culture, have always been like that. Now specifically these manas, I rearranged them in a particular sequence of decreasing durations of time. So if you look at Brahma mana, it includes parardha, which is a half-life of Brahma. The full life of Brahma is double that. And kalpa, which is a day of Brahma. Pralaya is the night of Brahma, and combine the two, that becomes a full ahoratra of Brahma. Then you have Manvantara, Mahayuga, Yuga. These are all large time frames. You come down to the bottom, you have Nakshatra, Ahoratra, Nadi, Vinadi, and Prana. These are like hours, minutes, seconds. So you see a scale from 155.5 to trillion years, coming all the way down to 3.989 seconds, which are arranged inside these buckets. So there is a framework. They structured these things, the time elements. These are the small ones, these are the large ones. And these ones which you are seeing, a Divya Ahoratra which you see here, below this is all astronomical. Above this, it kind of becomes mathematical, which says 1,000 years of the gods is a kalpa, is a yuga. And then it goes in steps of multiples. Now, out of these astronomical ones, we are mainly focused on two things, Chandramana and Sauramana. A lot of calendric elements which we use even today in the Panchanga will be found in Sauramana or Chandramana. And my focus today is Chandramana. I will talk to you about Chandravarsha, Chandramasa, Paksha, Tithi, not so much about Karana, but about Tithi. So what is Chandramana? Chandra is moon, Chandra is pertaining to the moon. Just like Surya is sun, Saura is pertaining to the sun. Sol, solar. Luna, lunar. Chandra, Chandra. So Chandramana is lunar measures of time. Again, the moon, deeply embedded in Hindu culture. Very popular song, I'm sure. I wonder if anybody in this room has used this song. Probably many of you, some of you might have used it. But we are going to dig into the calendric elements which are defined by this moon. And this is the structure. So at the outermost level, there is a year, Sauravarsha, and that is made up of 12 Chandravarsha, that is made up of 12 Chandramasa. The names are listed there. Each Chandramasa is 2 Pakshas, Shukla Paksha, Krishna Paksha, and each Paksha is 15 Tithi, Pratama, Dvitiya, Tritiya, etc. This is very simple. You can give it to any school and they will teach this in one class, and all the children will sit and Petra, Vaishaka, Jeshta, Ashada, Shravana, Bhadra. Dad, no, we know the Hindu calendar. No. There is a reason and astronomy behind why these are structured this way. And that's what makes this great fun to delve into. So to explain these things, I need to get into one bit of mathematics. Angles, elongation. It's an angular measure. And using this elongation, I will explain everything else to you. But the fundamental idea is, you've seen this picture already. So I am standing facing north, and I have Saturn, I have Shukra, Guru, Chandra, Mangala, etc. So imagine that's me or that's Aryabhatta, whoever you wish. they measured these angles like as if they had a giant protractor. That's why I said I don't know how exactly they measured it. That's a subject I'm not qualified to speak about, but they did measure this somehow. For example, in this picture, I'm saying between Shukra and Guru, 68 degrees gap. So it's just, there is Shukra, there is Guru. This angle, degrees, that's what we are working with here in our mathematics. So when I say distance between Guru and Shukra, I don't mean the linear distance. That will be like lakhs of kilometers. I'm talking angular distance as observed by me standing in Bangalore. What is the distance in angles? 68 degrees. More specifically, elongation is a smaller measure, restricted measure. You measure any planet with respect to the sun. Sun is the big boss. From the sun, how far is moon? That is elongation of the moon. From the sun, how far is Shukra? That's elongation of Shukra. Again, in these angles. It's in 3 dimensions, so we put it on 2 dimensions by, that's why I say measured along the ecliptic plane, but those details you can leave out now. And this elongation is measured if the sun is to the east, you measure it this way, but if it's more than 180 degrees, you switch angle and measure it on the other direction. So here is a stellarium screenshot. Elongation of Chandra is 119 degrees, 33 minutes, 16 seconds. Stellarium shows it there. And I marked it out here as an angle. Moon is to the east of the sun. Now moon is to the west of the sun. I mean, I can still measure it this way, then it will go beyond 180 degrees, but we are constraining it to less than 180 degrees by switching direction, west of the sun. This is a fundamental idea of elongation. Now let's get into the Panchanga. Basic concepts I'm talking about now. Amavasya and Purnima. New moon and full moon. Anybody can guess what new moon is? Elongation is 0 degrees. Sun and moon are together. Not that they physically crashed into each other. Of course, moon is closer, sun is farther away. But when I observe from the surface of the earth, sun is there, moon is also there. These are all very momentary, very fleeting because everything is moving. But the moment when they are together, when they are dwelling together, Amavasya. Elli Vasya Martiri means where are you residing? They are residing together. Amavasya. And in English they say it is in conjunction with. Same thing. Amavasya in conjunction, residing together. Who translated from whom? I'll let you guess. But the interesting thing is on Amavasya day, the moon will rise and set with the sun is rising. Actually, moon is also rising with the sun. Sun is setting, moon is setting with the sun. So you cannot see it, and even if you see it, the dark phase of the moon is facing you. Purnima is the exact opposite, 180 degrees elongation. So now I'm showing in the center the earth. The previous animation I showed you the big horizon going round and round. I removed the earth. I brought the earth back, not as a big line, but I'm showing it like a small ball, bhugola, earth ball. In English, the scientific term is terrestrial sphere, bhugola. Who translated from where to where, you figure out. So this is 180 degrees, and Purna, I think, basically means full and complete. So instead of saying Purna Chandra, it became Purnima. In English, it is full moon. These are the 2 basic markers in the Hindu Chandramana calendar, lunar calendar, Amavasya and Purnima. Now, based on these 2 markers, I will define Paksha. The first calendric element. Those are not calendric elements, those are markers. It's moment in time, it's actually fraction of a second, Amavasya is gone. Another fraction of a second, Purnima is gone, because sun is there, moon is there, they are moving all the time. What is a Paksha? What is the word Paksha? You know, in politics, Paksh, Vipaksh. It basically means side, opposing side. Paksh, Vipaksh. But here we don't have Paksh, Vipaksh, we have Shukla Paksha and Krishna Paksha. One is the bright side, one is the dark side. Which one is the bright, which one is dark? Again, you should make up your mind. That's politics. I won't go there. So what is the Shukla Paksha, Krishna Paksha? I will animate this and show you. So same as the previous one I showed you, I'm starting on April 12th, 2021, 6:23 in the morning now, 6:23:30, because that's the moment when they are both in the same ecliptic longitude, as I call it. They are in the same angular position. The gap between them is 0. Now let me play the animation. Shukla Paksha has started. The bright side of the moon starts becoming more and more visible. The silver side of the moon. Shukla is actually silver. Now it is fully silver and it has come opposite to the sun. Sun is there, moon is there in the opposite side. Now Krishna Paksha has started. The dark side of the moon is more and more visible to you. That's where these names come from. It's not named after Bhagavan Sri Krishna. It's the other way. Vasudeva is dark and hence he is Krishna. Back where it started, next Amavasya, Krishna Paksha, is over. So Krishna Paksha ends with Amavasya and Shukla Paksha ends with Purnima. In the first Panchanga picture also I showed you 28th February 2025, the Paksha was ending, so that was coming in the last row in that Panchanga. So these are basically fortnights. If you had followed the dates here, it would have been approximately 14 days. It will be 14.75 on an average. The exact duration will vary because though moon appears to be moving steadily, sometimes it's faster, sometimes it's slower. That's happening because this moon's orbit is not exactly a circle, it is an ellipse. So there is a constant variation in the moon's speed. And all these variations were handled by the astronomers whoever created Surya Siddhanta 1600 years back. So these are the two Pakshas, Krishna Paksha and Shukla Paksha. It's a summary of it and a much more simple picture. Amavasya to Purnima is Shukla Paksha, Purnima to Amavasya is Krishna Paksha. And Paksha is a fortnight, waxing fortnight, waning fortnight. That's what we are talking about. This one, Shukla Paksha, begins immediately after Amavasya, ends with Purnima. This is the reverse, begins immediately after Purnima, ends with Amavasya. Fundamental organizing unit of the Hindu calendar is a Paksha. It is a fortnight, not a Vara. In fact, in the Surya Siddhanta, I showed you the 9 manas. The Vara doesn't find a place there at all. Vara does get a mention somewhere else, not as a calendric element, but more from an astrology perspective. As the ruler of a day, ruler of an hour, those kind of statements are made there. Vara doesn't find its place. So for our calendar, Paksha is the basic organizing unit. In fact, I am told that in North India, many laborers would say, we don't work on Amavasya. So they are taking a fortnight end off, not weekend. Fortnight end. We are not working. We need a day off. Key differences from modern calendar. A period of 2 weeks is a fortnight. Weeks, Vara. Hours, Paksha, astronomical. Waxing and waning periods of the moon with an average duration of 14.7 days. How many days is it? We don't care, you figure it out. I'm an astronomer. I'm observing the moon, waxing phase, Amavasya, Purnima, waning phase. That's what I'm concerned with. That's my definition. How many days? Doesn't matter. This is a fundamental aspect of our calendar. That's why I keep saying this is 200% based on astronomy. So let me take a pause here. Are there any doubts from what you have seen? Okay, then let me keep going. So next I go to Chandra Masa, lunar month. So what is a Chandramasa? Very simple. It's composed of two Paksha. You put a Shukla Paksha and Krishna Paksha together, you get a Chandramasa. So what I showed you is actually a Chandramasa. You saw it. Begins immediately after Amavasya. From one Amavasya to the next Amavasya is a Chandramasa. And the duration is again on an average 29.5 days. Now interestingly, I found out that in two languages, Kannada and Tamil, the same word means moon and month. So in Kannada, what is a month? Tingalu. Everybody knows. Ee tingalu, hoda tingalu, barva tingalu, month. But can anybody tell me where the word tingalu refers to the moon? Specifically think of, exactly, thank you very much. Beladingalu, belada tingalu, full moon. So there, tingalu means moon. Same word it is coming to our language. Moon, month, same thing. Not January, February, March, but Paksha. Two Pakshas put together, which is defined by the moon. Same thing in Tamil. In Tamil, can somebody tell me what is Monday? Tingal Kidamai, moon day. That is Monday. But this one is harder. Can anybody tell me where Tingal means month in Tamil? Perfect. Thank you very much. I thought I will have to give you more prompts. It is the first verse in Tirupavai, which is composed by Andal. Margadi Tingal Madiniraindan Annalam. The month of Margadi. Tingal is month. And Tingal Kidamai is moon. Month and moon, same word. It comes into our language. So these are integral part of our culture, of our language. But we haven't got it. We forgot that astronomy completely. So now I have got another question for you. I have become Bethal and you are the legendary King Vikramaditya. So I just told you Amavasya to Amavasya is a Chandramasa. So it started with Amavasya, Paurnami, went back to Amavasya. So am I right in saying during a Chandramasa, the moon completes exactly one orbit? True or false? True. Right. It looks like it's true, right? Now, here is where our astronomy gets extremely sophisticated. I mean, these are actually basics of astronomy, but they are so lovely. The answer is actually false. It actually moves more than one orbit as we traditionally think of an orbit. Orbit means finished one circle, moved 360 degrees. I'll show you why I'm saying this. I play the same animation, the Paksha animation, a second time. Same starting point, Amavasya, April 12th, 6:23:30. So now Chandra is moving, but keep your eye this time on Surya. Don't look at Chandra. What is Surya doing? Is he standing still? I told you, Surya is also, there is an apparent movement of the sun. So this plus is where they started. So now you can already imagine that when the moon completes one orbit, next Amavasya is not going to happen. So now it's Purnima. So let's wait for it to come back to its starting point. Krishna Paksha is going on. So when the moon comes here, it finishes one orbit exactly, 360 degrees. But the month will not complete. So this is 27.3 days. Remember the days, 27.3, it finished one orbit. But it has to proceed to catch up with the sun. Now, the Masa gets over, 29.5 days. So it had to move an extra 30 degrees, not exactly 30. There are always these slight fractions which create a lot of trouble. So that is the Sukshma Vichara which we should observe. These are subtle points. I'm showing you Wikipedia. Moon, 2 orbital periods. One is called sidereal orbital period, 27.32 days, that is this. Another is called synodic orbital period, 29.5 days. That is this. This is a Chandramasa, so it moved more than one orbit. 30 degrees more actually. Instead of 360, 390 degrees, moon had to go to catch up with the sun. But the interesting point is, this 29.5 went into the definition of Tithi. I will show that to you in a moment. There are 30 Tithis in a Chandramasa because this is approximately 30 days, almost 30 days. Now, can somebody tell me this number 27? 27 nakshatras in the nakshatra mandala. You are a wonderful audience. Thank you very much. That number 27 was not picked at random. It appears like a random number, but it is not. I mean, it's a prime number, but who will pick 27? 25 I can understand, 30 again, 27. Because of this, it takes 27 days to finish one orbit. So you split that into 27 equal parts. Moon will cover each part in approximately 1 day. And that's why they created 27 nakshatra. In fact, in the ancient times, they thought this was closer to 28 and they defined 28 nakshatras. When astronomy became better, they realized, oh, this is closer to 27. So they just dropped Abhijit. We don't want you anymore. We will stay with 27 nakshatra. So nothing is random in the Indian Hindu calendar. Now there is one more thing hiding here. Can anybody spot it? That I will come to in a moment. Not here. Here what is hiding is this nakshatra I have said. Rashi is also hiding here. Rashi is the 30 degree segment of the ecliptic. 30, 30, 30, 30, 30, 30. You do 12 times, you will get one full 360 degree circle. So the 30 degrees for a Rashi was also picked because of this. This is the distance the sun moves when the moon completes one Masa. Moon completes one Masa, Amavasya to Amavasya, sun has moved one Rashi. Moon completes second Masa, sun moved second Rashi. Moon completes third Masa, sun moves third Rashi. Not exactly, because it's approximately 30 degrees, and that leads to Adhika Masa. And I will come to that in a little while. But when I hit upon this picture, I felt so happy because I think, as a man of science, I think there is beauty in this picture. It reflects the amount of knowledge which was available at least 1600 years back, probably much earlier. Siddhantic period, they definitely knew this completely inside out. And probably even before that, because Bhishma talks about Adhik Masa in Mahabharata. Every 5 years, 2 Adhik Masas are added. It's coming from this picture, from these concepts. So now that I told you about Masa, Amavasya to Amavasya, I have to backtrack a little bit. Amavasya to Amavasya is only one definition. This is the original definition in Surya Siddhanta. But we Hindus are very flexible. We have a second definition. So this is the first definition. Amavasya, new month begins immediately after Amavasya. But the second definition is you wait for Paurnami. Purnima, new month begins. Purnima to Purnima. Why Amavasya to Amavasya? Purnima to Purnima also. Okay, you want it, you take it. We'll let you do that. Two definitions of this. So this is called Amanta tradition, meaning Amavasya Anta, ending with Amavasya. If you know the meaning, then the concept registers very nicely. This is Purnima Anta. The month ends with Purnima. And I will start a new month. And by and large, northern India follows Purnimanta tradition, southern India follows Amanta tradition. And here is another illustration of the same thing. This month, October 2025, we are in October 5th. 2 days from now is Purnima. We don't care. Our month continues to be Ashwina Masa, that color. And we wait until Amavasya, then we start Kartika Masa. We meaning Karnataka, Bangalore. Whereas if you go to northern India, the moment Purnima ends, the next day they will start Kartika Masa. And they continue in Kartika Masa till here. So these number of days from 8th to 21st, we are in 1 month and they are already in the next month. They have moved ahead. So when Deepavali happens for us, we will say Deepavali happens in Ashana Masa. They will say, Deepavali happens in Kartika Masa. Same day, they just flipped the calendar earlier, 1 fortnight earlier. That's what is happening with the Amanta and Purnimanta tradition. This is an approximate picture of who uses which calendar. Southern India majority uses the Amanta calendar, Northern India the Purnimanta in green. Tamil Nadu and Kerala use a solar calendar, Sauramana. I'm not talking about that today. They will also use Paksha and Tithi, but not the Masa and Varsha. They go to Sun for the Masa and Varsha. Same way with the Bangla-speaking areas of Orissa, Kolkata, Assam, they also use the solar. Punjab has some traditions of solar, but predominantly lunar, but they also have solar calendar somewhere. But this is a rough picture. Individually, communities decide Amanta or Purnimanta. For example, I belong to a community from Tudu Nadu. We are somewhere here near Bangalore. We follow the Saura calendar, Sauramana calendar. Only Udupi, Krishnamata, we follow Sauramana, not Chandramana. We are in Karnataka, but our Panjangas will follow Sauramana. So a lot of flexibility. We are ಸ್ವಲ್ಪ adjust ಮಾಡಿ ಅಷ್ಟೇ. You just have to have this grasp of the astronomy. What's going on? Okay, this is what is going on. This understanding is essential to really appreciate what's going on with our calendar. Key differences: the Western calendar arbitrarily determines number of days of 30, 31, 30, 31. Whereas our Chandramasa is astronomically defined, synodic orbital period of the moon. In fact, I showed you 29.5 days is one Chandramasa. That's kind of the same thing which is happening in the Western calendar also, not 29.5, but they made it 30. But they wanted to synchronize with the solar 365 days, so some months they made 31. So this is all coming from the moon, even in the Western calendar, though they have forgotten the origin. But the original Greek calendar must have been a lunar month. Then I come to Chandra Varsha. Any questions here at this point? There are some questions at the back.
So there are days they add randomly, like last month when Dasra was there, one extra day came, right? And sometimes they drop it.
I'll come to that next. I'll talk about it in Tithi.
Okay.
Hello. So I was wondering what happens to the 30 degrees later on. So there's a nakshatra defined for each of the 27, but the last where the catch up happens of in the 3 days. So are there no nakshatras defined for that?
No, those would be completely different topics. I cannot address them now. So nakshatra is a separate topic. I have a presentation on that, and that Rashi is another separate topic. Sauramana topic. These are all, in fact, it's possible to do a series of lectures one by one. But right now my focus is to get this lunar calendar demystified.
Hi. So there are few communities in West Bengal who define a Masa based on Tithi. They do it Ekadashi to Ekadashi. So is there any astronomical basis for this, or is it something which they arbitrarily picked up?
No, I have not heard of that. Thank you. Thank you for letting me know that happens. Ekadashi to Ekadashi is a Masa. The definition would still hold, but I'm curious why it's not Amavasya to Amavasya. That's a different definition of the term Masa. Not as a calendric month, but more as the religious period of 4 months where you do certain festivities.
In one of the slides, I saw Samvatsara and Varsha. I've seen that for Samvatsara is also a Varsha. Is there a difference between?
Yes, yes. So Samvatsara in the Surya Siddhanta is actually based on the movement of Jupiter. Now, approximately Jupiter moves through one Rashi by the time the sun completes 1 year. Jupiter is, so there is an astronomical ratio. I'll come to that later. but Samvatsara is related to Jupiter's movement. But over a period of time, the term got morphed to apply to a solar year. So now solar year or lunar year also, we call it a Samvatsara and give a name, and there are 60 names defined, and then it rotates back to the first name. But the original definition is based on Jupiter's movement, Guru's movement.
The question is, you mentioned that there's a difference in the masas between north and south, right? One is Amantika, another one is the Purnimantika. Right?
Mhm.
Is it is it related to the weather patterns in these regions because of the sowing season or any of those things?
No. That Ritu will matter for that, but that is again solar, and that is roughly equated to lunar. My first reply is no, but I will think some more about it and see if that's a possibility. I doubt it very much.
Yeah, I would like to add up his question. He said that Samvat, I'm from North Indian, we say Vikram so Samvat, and currently we are in the year of 2080 something. So you said astronomy is something 1500 years back. How is this 2000, like extra 500 is how is adding?
Yeah, so that Vikram Samvat and Shalivahana Shaka are a different concept. They are the ways of numbering the years. Like we have Gregorian numbers, we are in 2025. There are two traditions for numbering the Hindu years. As Vikram Samvat, Vikram Samvat or Shalivahana Shaka, that is not at all astronomical. It is based on, like Christian calendar is based on 0 year is birth of Jesus Christ. So Vikram Samvat is based on something which the legendary king Vikramaditya did. So historians have to figure out what exactly was the event which was considered so important. They said, let's make that a 0 year and start from there. Shalivahana Shaka is similar. There are multiple theories as to somebody called Shalivahana king was the Shalivahana Shatavahana who defeated the Shakas in a battle. That was so important they made it 0 year. But that's completely non-astronomical. It goes more into history to determine the start of the numbering sequence. Now I'll come to Varsha, which is astronomical. And now Varsha definition is also straightforward, 12 months. You take 12 months together, it makes one Varsha. Modern calendar is also exactly the same thing. Chandra Varsha has a duration of 354 days. But here also there are a lot of Sukshma Vichara hiding there, which you should take a look at. Why this 12? Why did they pick 12 months? Why not 15 months? Why not 10 months? Why 12? Same starting point, this time the Amavasya got a name. Falguna Amavasya. This is my starting point. Falguna Masa is ending. Krishna Paksha is starting. I'm going to now talk about Masa. So one by one the names of the Masas will come. You know one Masa is Amavasya to Amavasya. So let me start the first Masa. I am accelerating the movement of the sun. I would cover now 12 times. You've seen this already, but now I added Chaitra Masa. So this was Chaitra Purnima and now this is Chaitra Amavasya. So Purnima and Amavasya got names now. The name of the Masa got added. Vaishaka Masa. Vaishaka Purnima. Vaishaka Amavasya. I continue to use the Amanta tradition in all of this. Now Jyeshta Masa is starting. Jyeshta Masa. Shukla Paksha ends with Jyeshta Purnima. Purnima is the middle of the month. And Amavasya is the end of the month. Jyeshta Amavasya. Now Ashada Masa. Shukla Paksha. Now clearly you can see the moon is a busybody. He is running like anything. Sun is extremely slow. The moon is like a rabbit. And every time the moon overtakes the sun, a new Masa starts in our Amanta tradition. That's why I like this tradition. Easy to understand. So if this was an F1 circuit, the sun is getting lapped again and again and again. So slow, the sun is plodding. So initially somebody asked about Nakshatra. Actually, there are a lot of Nakshatra around this circle, and sun is making its way slowly through the Nakshatra, like I showed you in the very first animation. But now my focus is on Masa. So this every time it overtakes new Masa. Now Bhadrapada Masa over, Ashvina Masa has started. In fact, the names are actually coming from names of Nakshatra. I'm not going into that today. Because Ashvina, there is a Ashvini Nakshatra corresponding to it. So Ashvina Masa over, Kartika Masa, now sun has come beyond the halfway point, but he is still a long way from finishing the first lap. So the first solar year is still going on and on and on, whereas 8 lunar months are completed. So now you can start imagining why there are 12 months in a year. Margashirsha Masa, Margashirsha Amavasya, 9 months are over. 3 more months to go. Pausha Masa Shukla Paksha, Pausha Purnima, and Pausha Amavasya. 10 months are over. So now the sun is making its way back to the starting point. That's where we started this animation. The first month started there. Magha Masa, Magha Amavasya, 11 months are done. Now let's see, in the 12th month, does the sun complete the first lap? Magha Purnima. And finally, we come to Magha Amavasya. So 12 months are over. But did the sun complete the first lap? Not yet, not yet. Is almost there, but there is still a small gap. And this gap is not enough to cover one more Masa. So we close the lunar year here. This is the end of the Saura Varsha, Chandra Varsha, Falguna Masa, Falguna Amavasya. Finishes off the lunar year. But let the sun finish one lap at least. Let's see how many days it takes. If you track these, you will be able to see that days also. 11 days, 10 point something, 10 days and probably 16 hours or something. Again, those will vary. The speeds are varying. So now a solar year is completed, finished off, came back to where it started. But the next lunar year started and sun has moved almost over 2/3 of Shukla Paksha in the next year, Chaitra Masa. So you must imagine, so the first lunar year, Chandrama Varsha stopped here, ended here. Next Chandramasa started here, then moon goes 12 times. The end of the next lunar year would be here, 22 days. It is cumulative. The lunar year after that will be 33 days, after that will be 44 days, after that will be 55 days. It will start drifting away from the solar year. In fact, the Islamic calendar, they allow this to happen without arresting it. So you know where this is leading. It's leading to the concept of Adhika Masa. Because of these 11 days gap between a lunar year and a solar year. 354 days, 365 days. So 354 days lunar year, 365 days solar year, and this gap has major implications in the Hindu calendar in the form of Adhika Masa primarily. Now I come to Tithi. Tithi I go reverse. I take a month and I split it into smaller parts. But before that, if you know Kannada, then this was a very popular movie. It was an indie movie, a great comedy movie. I think this old man dies and it is about his Shraddha. So Tithi in Kannada means Shraddha. That's what I grew up with in my house when I was a small boy. With Tithi, I know that Purohit will come. My father will do the ceremony, will push the dining table to one side and yele ota on the ground. That was Tithi. And now, after I became 50 years old, I realized there's a different definition for Tithi. So lunar day, time taken by the moon to increase its elongation by 12 degrees. There comes the elongation. Purely astronomical definition. I can't imagine something like this done by anybody else except Hindus. And there are 30 Tithis in a Chandramasa. So let's take a look at the animation now. Same starting point. I'm going to show you Chaitra Masa, Krishna Paksha and Shukla Paksha, but small periods of time, like multiple days within a month. Except now I'm showing you here a time stamp. April 12th, 6:23 in the morning was Amavasya. Now I move forward. Very slowly, 12 degrees. The moon moved 12 degrees from the sun. This is the end of Pratama Tithi, where the moon is between 0 and 12 degrees from the sun. And Pratama Tithi ended at 4:13, 8:42 in the morning. This is what is marked in the Panchangas. Tithi, 8:42 in the morning. They won't put seconds usually. Tithi ends at 8:42. That means moon came to 12 degrees. Pratama Tithi ends. It's so geometric. Now Dvitiya Tithi is in progress. 24 degrees. 12 to 24 degrees is Dvitiya Tithi. Tritiya Tithi is 24 to 36 degrees. And it goes on and on and on like this. And I'm giving you the durations. They kind of hover around 24 hours, sometimes more, sometimes less. Because like I said, moon's angular velocity is not constant. It keeps changing its speed. Panchami Tithi, 48 degrees to 60 degrees. And all these Tithi names keep coming in our festivals. Skanda Shashti. So they are actually referring to a Tithi in our festival name. They don't say Masa and Paksha, but Tithi finds a place in the festival names. Saptami Tithi, Ashtami, Krishna Janmashtami, everybody knows. So in the Panchangas, they are recording all this. In fact, many of the modern Panchangas are based on Drik Ganita, which was written in 1300s, 1300 AD. They had formulas and arithmetic to compute these tithis, these durations, based on the moon's speed. And depending on where you are, where your observation location is. Drik is a very popular one. Surya Siddhanta also has the formulas, but Surya Siddhanta is about 1,000 years older than Drik, so the formulas are less accurate. Drik is more favored nowadays. Now you are coming to Trayodashi Tithi. Chaitra Masa Shukla Paksha, that stays. Chaturdashi Tithi. Now finally we come to Purnima Tithi. So what's happening here is these Tithis names are actually nothing but counting. Pratama is first, Dvitiya is second, Tritiya is third, Chaturthi is fourth, fifth. ಮೊದಲನೇದು ಎರಡನೇದು ಮೂರನೇದು ನಾಲ್ಕನೇದು ಐದನೇದು ಮೊದಲಾவது ரெண்டாவது மூணாவது நான்காவது அஞ்சாவது counting in Sanskrit pratama dvitiya tritiya chaturthi panchami shashti saptami ashtami navami dashami, das is 10 dashami, and after that we go to ekadasha 11, dvadasha 12, trayodasha 13, chaturdasha 14, and instead of saying panchadasha we reuse this word, in this case Purnima Tithi, because it's leading up to Purnima. From here to here is Purnima Tithi, but this moment is itself Chaitra Purnima. This moment is a fraction of a second, Chaitra Purnima, but Purnima Tithi is 21 hours, 34 minutes, 18 seconds. In this particular example, on that time. So we just reuse the word Purnima again as the name of a Tithi. Now the moon is going back. So the angles start reducing. We are measuring in the other direction. 168. This is why I said once it exceeds 180, you switch the direction of measurement to the west, 156, and it starts reducing back to 0. Slowly, slowly. Same Tithi names are reused, Pratama, Dvitiya, Tritiya, but Krishna Paksha. So 15 names are used to denote 30 Tithi. 15 for Shukla Paksha, 15 for Krishna Paksha. So Saptami, like I said, is 7th Tithi. Ashtami is 8th Tithi. Another thing I want you to observe. So here you are coming to Navami Tithi. It ends at 1506, 3:06 in the afternoon of May 15th. Next, it moved to 1556. Next, it moved to 1732. It's gone into the night. So here, if you see, Tithis are ending at 2 in the night, 1 in the night. This is 10 o'clock in the night. This is 5:40 in the evening. This is 2 in the afternoon. One Tithi ends, another Tithi begins any time of the day or night. It doesn't care. Now we are coming back to Chaturdashi Tithi end. And now the moon will go back to the next Amavasya. Amavasya Tithi now, not instead like Purnima Tithi, now it's Amavasya Tithi. So this picture I showed you right in the beginning. I said if you see this, you are coming to the end of the talk. So that is about Tithis. Now Tithi and solar days, I already pointed out, Tithi doesn't care about sunrise, sunset. Tithi can end, next Tithi begin any time, day, night, it doesn't care because it's all about moon's angles. Who cares about sunrise, sunset? But our life is governed by the sun. We all rise with the sun, we start our day's activities, and ideally we should set with the sun. We don't nowadays, too much electricity and TV and WhatsApp and all that. But we are forced to correlate Tithi with solar days. It makes sense. What is the Tithi today? How do I answer that question? So what we normally do is, as a convention, we just take, this is the sunrise of today, 5th October 2025, Bangalore mein sunrise was at 6:09. At that time, the Tithi was Trayodashi. So we say whole of today is Trayodashi Baba for convenience, for pragmatism. In fact, right now as I am speaking, we have moved into Chaturdashi already. Right, we are at 7:15, so somewhere here, it's already Chaturdashi, it's marked here. This is from a website called Indian Panchanga. So we take the sunrise point and we decide what the whole Tithi is. And sometimes an entire Tithi gets embedded between two sunrises, in which case we say it's Akshaya Tithi. It's lost Tithi, let it go. Sometimes it extends across two sunrises, in which case we say this is Adhika Tithi. It's all to do with sunrises. So now that you know all this, you know in the Hindu calendar, you don't say 5th October, you say Ashvina Masa Shukla Paksha Trayodashi Tithi today. It's actually Chaturdashi, but sunrise it was Trayodashi. So, but if you are celebrating some specific wedding, muhurta or festivals also, Purohits will look very carefully. Oh, it's already switched over to Trayodashi, they will consider that. But otherwise you say today is Ashvina Masa Shukla Paksha Trayodashi Tithi. 2025, instead of that, we may use a year number. I'm not showing it here, either Shalivagna Shaka or Vikram Samvat. That's non-astronomical. Very important day for everybody's birthday. So that is from my previous avatar. That was how I made my YouTube videos, because I went outdoors and did them. So my birthday is, I always think of it 25th July 1962. My birthday is Ashada Masa Krishna Paksha Navami Tithi. That is how I should really think about my birthday. And more than that, if I come to festivals, a lot of Hindu festivals, majority based on Chandramana calendar. In fact, there is a shloka, Tithi Karanamudvaha Shauram Sarva Kriyastata Vrathopavasa Yatranam Kriya Chandrena Grihiyate. So he gives a list of things to which you should look at the moon. Tithi Karanam Udvaha is wedding, Shauram is shaving, Sarva Kriya Stata Vratha Upavasa Yatranam Kriya Chandrena Grihiyate. You look at the moon and do all of them. Basically, all religious rites. It's not explicitly saying festivals, but all religious rites. Look at the moon. So now we come to the main thesis of today's talk. Why do Hindu festivals occur on different days? Ramanavami was on 17th April last year, now to 6th April this year. What's going on? It actually happens on the same day on our lunar calendar, Chandramana calendar. But our tithis occur every 354 days, not 365 days. If you keep that in mind, then things will start falling in place. There are complications. So these are the festivals, and these dates don't change. This is the dates as specified in our Chandramana calendar. And the next festival which is coming up is Karwa Chauth. And Amanta we say Ashana Masa Krishna Paksha Chaturthi Tithi. Purnimanta will say Kartik Masa Krishna Paksha Chaturthi Tithi, but it's the same Tithi actually. And then comes Dhanteras, Naraka Chaturdashi, Deepavali, Bali Padimi, Bhai Dooj on 5 consecutive days, Trayodashi, Chaturdashi, Amavasya, Pratama, Dvitiya, 5 days split across 2 months. So this is our Hindu festival calendar where it doesn't change. But when you take this and put this on the Gregorian calendar, then things change. So Ramanavami was on 21st April in 2021, but next year it won't happen on 21st April because that will be 365 days. It will happen 354 days later. So it comes approximately 11 days earlier, 10th April. Next, it advances by another 11 days to 30th March. Then it will another 11 days, it should keep on drifting, but we push it forward by introducing an Adhika Masa. I can't go into the details, but this is why an Adhika Masa is introduced, so that festivals don't drift off. Then it will go to February, January, Ramanavami happening in December. Very confusing. Seasons particularly is very important for us. So we push it back by pushing an Adhika Masa in there. Here is a little bit more detail. It would have fallen back 11 days, but that same year, 2024, we added an Adhika Masa, which is 29.5 days. There are all fractions involved, but net it will come forward by about 18, 19 days. It jumps forward. So it leaps forward. So this is our leap year. Not a single day in February, one full month we throw in there, push it forward, and then we let it drift back, again put 1 month, move it forward. This pattern is very much there in our calendar. And this is the pattern. I went and sat to the online Panchanga, looked at where all Adhika Masas came, just plotted it. There was Adhika Shravana in 2023-24. Here I put Shaka year numbering. Then after 2 years, in the 3rd year, there was an Adhika Masa, Adhika Jeshta, and then the real Jeshta, Nija Jeshta. Another 2 years, Adhika Chaitra, and then Nija Chaitra. After that, the pattern broke. Another 1 year, and then Adhika Bhadrapada, Nija Bhadrapada. So there is astronomy behind this, but it's again more elaborate animations I have to explain why they decide to add an Adhika Masa here. It's about a Masa without any Sankramana happening inside. But then what is Sankramana? That's in the solar calendar. So there is a lot of things which blend in to make this calendar. But this is the concept of Adhika Masa. So now I make some concluding remarks. I am at the end. So this whole thing which you saw, it's actually a celestial clock. I showed you the sun and moon moving, but here I put a sun hand and a moon hand. And when the two hands come together, it's Amavasya. When the two hands are opposite, it's Purnima. And the two hands are away by 12 degrees, 24 degrees, it's 1 Tithi. So it's a calendar which is up there, ticking in the sky. Difficult to read, but it's ticking up above our head. It's like a huge dial on top of our head. And in fact, there is actually a physical calendar which has been created by a company called Sri Astro Time. I have this, a beautiful product. It's in real-time clock. My animations, I speed up time. They don't do that. It's a real-time clock, and it's not just Chandramana, but Sauramana also. A lot of, and Nakshatra, everything they have put in there. But more interestingly, in our Hindu tradition, this is a celestial dance which is being played out in the sky. And there is a old Bharatanatyam shloka which goes as Angikam Bhuvanam Yasya Vachikam Sarva Vangmayam Aharyam Chandra Tharadi Tvam Namas Satvikam Shivam Shivam Shivam. The meaning of that shloka is, in Bharatanatyam there are 4 abhinayas. Angika abhinaya is a bodily movement, that is a dance. Vachika abhinaya is the words which accompany, the music, the sounds, without which there is no dance. Aharya abhinaya is the ornamentation, the costumes, etc. And Satvika abhinaya is the real emotion which is conveyed by all of these coming together and more facial expressions to touch your soul. That is what we normally think of as abhinaya, the expressions. This is for a human dancer, but what if the dancer is divine? What if the dancer is Shivam? He has no form, he is formless, he has no body. So what is his Angika abhinaya? The Angika abhinaya of Shivam is the movement of the entire universe. Take a look at this.
Angikam Bhuvanam Yasya Vachikam Sarvavangmayam Aharyam Chandra Taradi Tam Namasatvikam Shivam Shivam Shivam.
So we take the movement of the entire universe, the cosmic dance of Shivam. We look at one small portion, the sun and the moon dancing. And we encoded it in the Panchanga. The Panchanga has survived over millennia because our culture kept it alive. But the astronomy has been forgotten. And it's my endeavor to bring that astronomy back so that we get a better understanding of the Angika abhinaya of Shivam. So on that note, I end my talk. Thank you very much for watching so attentively.